Okay, let's do some boards go up, please, for some triple integrals. Like I said, we're doing triple integrals. We're going to start our triple integrals unit today. And in order to jump into it, what do you think we're going to do? We're going to do a double integral. So I'd like to see you, I'd like you to go ahead and calculate this integral right here. I want you to do the double integral over R of f of x y dA, where the function is 4 minus 2x squared minus 2y squared, and the region, this should be a capital R, the region is a circle of radius root 2 centered at the origin. So pause, go ahead, do it, flip over to my answer. I got 4 pi, so in order to get that region, I quickly said, I'm definitely going to do polar. So I went 0 to 2 pi, and then 0 to root 2, because that was the radius, of 4 minus 2x squared was r squared cosine squared, y squared was r squared sine squared. Another way to actually do that is to take 2 and then take a negative 2 and then go x squared plus y squared, and then recognize that in polar, right, this is the radius, this is x, this is y, this is r squared by Pythagorean theorem. So you don't necessarily have to use the Pythagorean identity, although it would get me to the same thing. It would give me 4 minus 2 r squared, right? 2r squared would be that. I got my RD theta. You're like, stop rambling, dude. Okay, so I do integral from 0 to 2 pi, integral from 0 to root 2 of this after I simplify with the r and RD theta. That gives me this 2r squared minus a half r to the fourth, evaluated from 0 to root 2. I miswrote it, but I did it correctly down here. So I plug in a root 2, do some math. I wind up getting 2 for all that. And then I do the integral from 0 to 2 pi of that, which is that winds up multiplying this by 2. So I get 4 pi. So hopefully you're good with that. Now go back to the Google Doc and it'll tell you what to do.